Hi, this is Mrs. Elkins. We're going to work on factoring the sum or difference of cubes, and let's get started. The first thing you really need to do is sort of recognize a cube when you see it. So here I've got a list of values from 1 to 11 and the cube right underneath them. So for example, 1 cubed is 1, 2 cubed, which is 2 times 2 times 2 is 8, 3 cubed is 3 times 3 times 3 and 27, and so on. So just kind of be aware of these numbers. You can always, of course, use a calculator to double check, but you'll be seeing these in some of the problems we're working on today. Definitely want to be familiar with the first few of them anyway. All right, let's get started. The first thing that you're going to do is you need to memorize or write down the pattern for the sum or difference of cubes. This is just like the difference of squares when you're factoring quadratics. Only the beautiful thing about cubes is that there's actually a pattern for both the sum and difference of cubes. And what we can do is just kind of verify that this works. I'm going to go ahead and verify that this is an equivalent statement by multiplying the second one, the difference, okay? And if you look, you'll see that if I take my a minus b and I multiply it times this trinomial at the back end, I would have a times a squared, a times ab, and a times b squared, right? So in blue underneath here, I'm going to go ahead and, actually I did that one in yellow, so that's going to be my, all this, I'll put a little star by there. I'll use green for the next one. I would need to take my negative b and multiply it by all three of the terms. So let me go ahead and do those, and I'll write those down. Negative b times a squared is negative a squared b. I'm going to write that right down here. All right. And negative b times ab is negative ab squared. And I'm just kind of writing it underneath its like term from when we did the products where we multiplied a times everything. And then, of course, the last one is negative b times b squared. Well, negative b times b squared is negative b cubed. So you kind of notice, because we lined up all the like terms, that when I bring these down, I get a cubed. Okay, and then right here I'm going to have a positive a squared b and a negative a squared b. That's 0, so I'm not going to bring anything down. Same thing here. All of this cancels out and gives me 0. So I'm going to bring down my negative b cubed. All right, so it's kind of verifying that those formulas work. Take a minute to go ahead and jot these two formulas down, and we're going to use them in our next problems. Go ahead and pause the video, because I'm just going to move ahead. Okay, I'm going to number these problems 1 and 2, and we'll start with problem number 1. What you need to do is be able to recognize what the cube is. Let me go back to the formulas. The formulas usually are represented with a and b as the variables, so you need to know what the a is and the b is. Okay, in this particular problem, my a, okay, is actually x. So it's actually the x that's getting cubed. My 8, I got to figure out what number it is that is being cubed. Well, 8 is the same as 2 cubed. So what I have here is x cubed minus 2 cubed. So in the formula, the a is represented by my x, all right, and the b is represented by 2. Now, some people are tempted to call that negative 2, but remember, I'm going to be using the difference or the sum of cubes formula, whichever one applies. In this particular case, because there's a minus sign, I'm going to be using the difference of cubes formula, and just by its nature, since I'm always subtracting, I'm going to be using positive numbers for my a, for my b. All right, so I'm going to rewrite that formula, and we'll just plug in the values. Okay, I've got a minus b. Okay, and there's all times a squared plus ab plus b squared. I'll just pause for a second. I'm going to go back to those formulas. There's something I wanted to point out about them. and I'm going to erase all this writing here and here. Okay. We're talking about the two pink formulas. You'll notice one thing I really kind of like about them is that each one of them has a binomial and a trinomial. And they're really identical except for the signs. In the first one, which is the sum, I have one negative sign. And it's going to be between the first and second term of the trinomial. In the second one, which is a difference, I have a negative sign in the binomial in the front. So both of them contain one negative sign. Just kind of remember where it's placed. Okay. Now, the problem we're just working on is a difference. So we've got the negative sign right here. All right, so let's keep on going. Now, what we're going to do is we're going to plug the x everywhere I see an A. I'm going to put little dots there. I'm going to turn that into an x. Okay. And everywhere that I see a B, I'm sorry, yeah, B, I'm going to plug in my 2. All right. So that's going to be right here, and right here, and right here. Let's go ahead and do that. So instead of A, I'm going to have X. And instead of B, I'm going to have a 2. Okay, now here, instead of A, I'm going to have an X. Instead of A times B, what I have is X times 2. Now just remember that when you're multiplying a number and a variable, the proper way to write it is with the variable, or with the number first. Okay. And then my B squared. So instead of B, I'm putting in a 2. Ooh, wait a minute, that's 2 squared. Okay, I could either go ahead and write this as 2 squared and rewrite the whole thing, or I can just go ahead and do the mental math, which is 2 squared is the same as 4. And that's it. You're done. You're done with factoring it. All right, let's try one more. The difference between the first problem and the second problem is that this particular one has a coefficient, which makes it a little bit harder. Okay, this is also a difference problem, but it's going to be a little more tricky because I want to know what A is. So the A is what is being cubed that would give me 8x cubed. Well, this is the same as 2 cubed x cubed, which is also the same as 2x cubed. Okay, 1, well, 1 is this 1 cubed. Okay, so just to be kind of really clear here, my A is this. This is my 2x. Okay, that's going to be my A. And my B is equal to 1. All right, I'm going to do the same thing I did in problem number 1. I'm going to replace my A with 2x and my B with a 1. So I'm going to kind of walk through this one slowly. Put a red dividing line between these two problems to make it a little, give us a little cleaner space. All right, let's start with, I'll use green. I'll start by just writing this out. So open parentheses, my A, well, that's 2x, and minus B is going to be minus 1, close parentheses, right? Now I'm going to start the trinomial piece of it. Okay, this is where it gets a little tricky. My A is 2x. So what I'm really doing is I'm going to go write it in parentheses. I'm going to square 2x, okay? And now I've got to do the AB part. Well, A is 2x, okay, and it's times my B value, which is 1. And this is all plus B squared. Well, in this case, my B is 1, so this is 1. Let's clean this up a little bit, the second trinomial. And what I'm going to do is take my 2x squared, quantity 2x squared. Or just remember that when you have you're raising an expression with an exponent, they both get squared. So this becomes, well, rewrite this here. This becomes 4x squared. Okay, all of that. Now over here I've got 2x times 1. Well, that's just 2x. And then I got plus 1. All right, we're done. We're done with that problem. You've got a binomial and a trinomial. And we'll move on to a couple more, a little more complicated. The first one says 125x cubed plus 27. Well, the cube root of that is 5x. Okay, because the cube root of 125 is what number times itself 3 times would give me 125? or what number, so 5 times 5 times 5 is 125, just as x times x times x is x cubed, okay? So we call that the cube root. My a value, therefore, is 5x. Now my b value is 3 because 27 is the same as 3 cubed, just as 125x cubed is the same as 5x cubed, okay? So in this particular case, my b value is 3. All right, so I'm going to rewrite this whole formula. I'll rewrite this one because we used the difference of squares in the last one. So if you remember, this one is a plus b times a squared minus ab plus b squared. Okay, let's plug in our values. For my a, I've got 5x, and my b is 3. Okay, now here I've got a squared. Well, a is 5x, which means 5 squared x squared, or 25 x squared. Okay, my a value is 5x, my b value is 3, so I'm multiplying 5x and 3 together, so I'm going to get negative 15x. Okay, last I've got b squared, my b is a 3, so this is going to be plus 9. Okay, take a minute to kind of look at that. Not too bad. I'm going to go ahead and do the other problem. Here I've got 1000x cubed is the same as 10x cubed. And 64 is the same as 4 cubed. I'm going to plug this all into the prior formula, which was the a minus b times a squared plus ab plus b squared. Okay, just going to leave it there. You wouldn't normally write this down each time, but for the purposes of this video, I'm going to do that. Okay, I'm going to plug in 10x for my a and 4 for my b. In the trinomial, my a is 10x, and since I'm squaring 10x, I'm going to get 100x squared. Now a times b is 10x times 4, that's 40x. And last, b squared, well, b is 4, so it's 16. Okay, there you go, and this is how you factor cubic polynomials. I'm going to try one more, to squeeze in one more problem here, and that's just if you had a cubic polynomial. This is actually the last one we just did, right here, number 10. I'm going to go ahead and show it already factored. Let's say that instead of just factoring this, it was equal to 0. The prior problem wasn't equal to anything. It was just an expression. Okay, so I'm adding on equal to 0. Well, we know by the zero product property that either this binomial or this trinomial, one of those has got to be equal to 0, or you wouldn't have a product of 0. So to solve, you'd go ahead, and I'm not going to do the quadratic formula for the second part, but I'm going to just kind of show you. We'd know that either 10x minus 4 equals 0, or all of this equals 0. For this one here, the trinomial, just use the quadratic formula to figure out what values there would be, or what solutions there would be. And for this one, we're going to set it equal to 0. Oops, I'll put a little in there. So if 10x minus 4 equals 0, then 10x equals 4. Or x equals 4 over 10, also known as 2 over 5. Okay, or the values we get here. Thanks for watching the video today.